Okay, moving on to integration by parts. So, naturally, if you have a different version, your question will look a little bit different. But in terms of difficulty wise, I think this is a good question to go over. I'm debating on doing a video on a different problem, but it's so hard because there's just so many different questions. But hopefully, this just kind of gets you an idea of how to do this. Okay. So, integration by parts. Now, listen, integration by parts only works when you have integral of function times another function. Do you see a function being multiplied by another function here? If you do, I suggest to look again, okay? This is division, all right? So I can't just start declaring what my u and what my dv is here because I don't have a multiplication yet. I need multiplication first. That would be like me giving you, e to the x times x to the fourth and asking you to do quotient rule. You can't do quotient rule yet because there's no quotient, you know what I'm saying? So step one is if you don't have two things being multiplied together, rewrite it so that they are being multiplied together, okay? So the good news is we can always turn division into multiplication, provided we understand how this works, okay? So, first things first, square root of y. Hopefully we understand that that's the same exact thing as writing y to the 1/2, okay? Now, another trick we can use is if I have something like this, 1 over x, that is the same thing as x to the negative 1. Okay? We're going to leverage both of those things in our integral. Okay? Because division by the square root of y is the same thing as multiplication of y to the negative 1/2. Okay? That'll definitely be something that shows up. So make sure we know what's going on. All right. Now, if you see ln in a question that is integration by parts, you're probably going to freak out. But the good news is that's always going to be your u, like every time. Because do you know what the integral of ln is? I don't. I should. But I do know what the derivative of ln is. Provided it's just ln x, then its derivative is 1 over x. But be super careful. If you're doing the derivative of, I don't know, like ln of, I don't know, x squared plus 1, is its derivative still 1 over x? No. It's the derivative of x squared plus 1 over x squared plus 1, which is actually 2x over x squared plus 1. So just be super careful, okay, when you're doing the derivative of ln. All right, moving on. ln will always be our u because we don't know its antiderivative, okay? For the love of God, please read the question carefully. So please state all of these. As someone who grades your exams, please just read the question and do what it asks. It's easy points. I can't tell you how many times it's just a reading the question error that can save you some points. Okay, so I have a multiplication. I'm ready to break this up between u and dv. So, u and dv. Like I just said, if you see ln is always going to be your u because we don't know its antiderivative. So we're not going to take its antiderivative, okay? That means dv is going to be everything else. All right, so from here, we need to, so it says to state u, du, v, dv, but really we can only state u and dv, and then we find du in v. Okay, so that's a little bit interesting verbiage, but that's not the problem here. All right, so derivative of ln of y is going to be 1 over y, which is great. And then v is going to be the antiderivative of y to the negative 1/2. So anytime we do the antiderivative of something with an exponent, we increase the exponent by 1, divide by the new exponent, okay? Meaning the antiderivative of y to the negative 1/2 is going to be y to the 1/2, because negative 1/2 plus 1 divided by negative 1/2 plus 1 is y to the 1/2 divided by 1/2. Now, I hate the way this looks, so I'm going to write this as 2y to the 1/2, because division by a fraction is multiplication by the reciprocal. Okay? Great. Now we have our v. Okay. Now, I'm not sure if the formula is on the cheat sheet you get, but we do need to use the formula for integration by parts, which is u times v minus integral of v du. So I like to write it in this way, so it's easy for me to remember that. So I go u times v minus integral v du. Okay, so this integral that we're trying to write, or that we're trying to find, sorry, is equivalent to 2y to the 1/2 times ln y. That just stays there. It's done. No more calculus needed for u times v. But then I need to do integral v du, so that's 2y 1/2 times 1 over y dy. Okay, I'm running out of room. That's fine. So now what we need to do is we need to evaluate this integral here, the second integral. But let's just kind of clean it up, right? Anytime you see a constant, just for your own sake, just pull it out here. Just pull it out in the front and forget about it for now, okay? Now, y to the 1/2 divided by y. All right, you see that? Multiply by a fraction, same thing as divide. Okay, great. Well, if I'm dividing two things like that, I'm going to subtract their exponents. So that's going to be the same thing as y to the negative 1/2, because y to the 1/2 divided by y is y to the 1/2 minus 1, which is y to the negative 1/2. Okay? Which we now know how to do. Okay, let me bring all this down so we don't forget about it. That's a y, not a 4. Okay, and now we're going to evaluate that, which we kind of already did. So hopefully we're good there. So we'll have this minus 2 times this antiderivative, which again, we did it earlier, so hopefully it's still fresh. Okay, the calculus here is done. Maybe we multiply the 2's together to get 4, right? We like that? All right, this question does have bounds on it. Your question on the test won't, so I'm not even gonna worry about it here. Just don't forget a plus c. Okay, so here we're done.